Hello and welcome to Diana's Makerspace. Today I'd like to show what's being done on the 65816 project. So let me show you some of the new things I've added since I've last shown this. Now when looking at the project, you can see there are a few things I added over here. Basically, you can see basically an 8250. This is an 8255 Intel port controller, two 74138 multiplexers, a 7404 NAND gate, and what happens, it uses address lines A1 and A2 to control it off a common data bus. Now the theory behind this is rather, since the 6502 has memory map control, what I did was basically just put it, so let's see if this comes out a little bit better. So I put it so you can see what it looks like that though. And then basically, so what happens is what we're doing is we're using the two muxes, one here and one here. So again, one here. Let's see, maybe if we do it this way, let's see. Okay, I think this is better. I had the wrong orientation. So using two 138 muxes, one here and then one down here. So what we're doing is we're using F12 as the gate to trigger the mux, and then F13 and 14 to figure out breaking the different sections between F0 to F7. So basically, so 80 to F0. So when this comes out, you can see I'm going to jump negative S7 over to negative gate 2. And then again, I'm going to use the same idea. So this, it'll start at 80, and then it'll start at 80, and then it'll go, then 800, and then it'll go all the way up to F00. Now, 12 bits, not 16. So this starts with the base address of F00, and then it adds the 800 to FFF. So what happens this way, basically, you could put the reset vector on F8. And you can put other devices here. What I'm doing is I'm linking the 8255 to F00, and then using A0 and A1 to make F00 to F003. And when you look at this, you can see from the design that basically this allows use of a port-based chip like the 8255, but used on a memory map basis. Now it sort of looks like a tangle of wires, but they all have the order. Most of these are data wires. This is the address wire that's going over here. This will be a flash RAM, and there's even room to add this extra static RAM in here, or even a 6510 serial port. And I like using Intel old Motorola chips for that, because it's sort of a lot. They still have a lot of use even today's systems. And then you can see this is the variable clock controller. And the thing is, you do have to have a minimum clock speed of 10 kilohertz for the processor to work. And then this is the reset start button. This is the opcode. This is the opcode tester, which is set to E0. And then you have two other buttons that set the memory. So the black wire sets the power for a 32-bit chip, and the white wire sets the power for a 28-bit chip. Now, what I'm planning to do is expand these into different major modules. Because I have a Z80, I have a 68000. The next thing I'm going to do is a PIC controller, PIC 16F and PIC 18F. Start working with the microchip and implementing that with the Arduino chips. I use the ESPF and the and the ESP32 and Arduino. So basically make a symphony of systems. And in addition to the gamer AI system, which I'll show in another video, I'm just waiting for some parts to come in. I'll show you what that looks like. Well, let me know what you think. I prefer if you leave comments on YouTube or leave comments on X at Diana1A or X at Ideas with Diana. And I'd like to thank you for watching, and I'll see you soon.